So we are Dallas software developers. You could be anywhere in Dallas right now. You decide to hang out with us. We take that very seriously. So thank you very much for being here with us and being part of the community. We do meetups about every 2 weeks, give or take. And our meetups are kind of structured a little bit differently than probably the average group, right? We do a lot, and it's not just only technology focused, it's community focused. And so a couple shout outs. Before every meetup, we kind of do this. Number one, big shout out to Yum Brands, the building that we're in. They give us the space for free and they support us. So please, huge shout out to them. Perfect. All right, I see on the online chat, we got a couple first timers. There we go. Thanks for hanging out with us. You're not here in Dallas, but you can be an honorary DFWN for the day. All right. And big shout out again to our second sponsor, the reason why we have pizza right now, Appright. Appright is a backend as a service tool. They always support us, even when we go over budget like tonight. So big shout out to Appright, please. Thank you. And if you haven't already, highly recommend checking them out. Their Discord is phenomenal and it's always active. Great open source tool. Really like them a lot. If you don't know who I am, I'm Danny Thompson. I am officially the Director of Technology at This.Labs. I started my new job a week ago. I know a lot of people were asking me about that one. Thank you all online, appreciate that. And so we do a lot of cool things. I kind of alluded to this at the last meetup, but essentially I am over several teams. We're working on a lot of big cool things. It's a tech consultancy company with kind of like a twist. We work on some of the coolest problems on the internet that some of y'all may not even be aware of. And one that I've been referencing over and over again is we help build the React docs with the React team. So that is like one of the big things that we can publicly talk about, among other things. So we work on some really cool stuff. Thank you for all the love online. I just saw the chat. Thank you. So a couple things. You're in a room right now. Tonight is a night of .NET. And so I know I have no .NET experience, so don't expect me to give a talk on this one. We have our amazing admin who is one of the speakers tonight, Dennis Garcia. He really wanted to spearhead this one, and he was really excited about doing a night of .NET. So big shout out to Dennis. On top of that, we have another admin helping out tonight, and his name is Dennis as well. We like Dennis so much, we brought another one. So Dennis is, he actually works at Yum Brands as well. If you were here for the mock interview night, he was one of the interviewers, and really big shout out to him. He's right here in the front as well. Big shout out to Dennis. We have several other admin. We have Clint in the back, who is also part of mock interview night. He was giving some interviews. He did like system design interviews, which were blowing people's minds. So good feedback on that one. Hopefully we're getting some people up for that. Clap for him, please. And if you've been a reoccurring member of our meetups, you know one of our big people, Eric Anderson. He's with us in spirit. He's okay. He's just not here tonight. So big shout out to Eric. Eric, we love you, brother. Hopefully, you'll be better again and hang out with us soon. Also, big shout out to our other organizer, Melissa. She can't be here tonight. She was out of town and schedule conflict. But if you're in the Discord and active, you're probably aware of Melissa, among the others. If you're in the Dallas area and you're not in the Discord, I highly recommend checking that out. It is very active with software developers that are local to the area, and it's a great way to kind of connect with the local community. So with that being said, I kind of want to address one thing before we kind of get everything started tonight. It revolves around the subject of networking, since we are in a networking kind of environment, but it's not necessarily focused on juniors, because I don't think this is a junior problem. We were talking about this a couple of weeks ago. We were talking about networking in general, and we were kind of approaching it from like the junior perspective. And I can tell you, I've always known this is like an issue at all levels, but nothing became more evident to me that senior developers and engineering managers alike suck at networking after posting those jobs that we had open. Because I'm talking about people with 10 years, 12 years, 14 years of experience are literally their DM saying, Danny, I need a job. I have 14 years of experience. How is that networking? How is that presenting yourself in a way that makes me want to have a conversation with you? Why do I have to start going through the back and forth of what is your tech stack? Are you qualified? Do you know that? I don't need to go through that. You need to be approaching this in a much more focused way. Tonight, you're in a room, and online, you're in an online virtual room with people that have very similar interests of what you are, what you're about, and what you're into. network with them appropriately. We gave out name tags. I kind of advise people, but I think I neglected on a couple tables to say this. Under your name tag, and don't just do that at this event, do this at other tech events that you go to. Under your name, write the core technologies that you're into. And so as you're networking, if someone's saying like, oh, you know React, I like React. What do you think about React 19? You have an organic conversation around the things that you're into. You're into .NET. You could talk about different versioning and things that you're working on and problems that you're solving. That helps you develop those conversations. So think about that as you're in the room. This room, pretty packed for a .NET room in Dallas, I think. So this right here could be an opportunity for you to make some real connections, friends, and people that you can just geek out about and geek out with after tonight, right? Don't walk away with the hope and memory of talking to somebody and then regretting it on the drive home. Do it. People are in here because they want to learn something new. We have some amazing speakers that are going to share knowledge, but more so than that, I think it's a great opportunity to walk out with some new connections. Because I can tell you right now, there are people in this room that I've literally seen firsthand come to an event not knowing anybody, walked out knowing people, and now they're friends and they're talking on the Discord all the time. That should be the goal for a lot of people, because those can end up becoming referrals down the road or anything like that, right? I think from there, we can kind of get into the talks. I do want to give one very large shout out. We had a very, very special guest fly in all the way from the West Coast for this, Nick right here. Big shout out to Nick. So the way this night is usually structured, a night of is our theme and our take on a mini tech conference. We don't charge anything for this. We bring multiple speakers with multiple ideas and sessions. It's completely free for the community. The ultimate hope is you get a conference-like experience in a very short period of time, but you walk away feeling like you learned something and maybe have some things to research afterwards. Traditionally, the talks are structured to be 10 to 15 minutes max. Since Nick was so generous to fly down and he spent thousands of dollars to be here, he can go for 16 minutes. So, you know, people always ask for extra time. That's how you do it. You get the extra minute. But outside of that, one speaker couldn't be with us tonight, Brittany Frank. She couldn't make it, unfortunately. We're hoping that she makes it to an event really soon. But so for now, instead of 5 speakers tonight, we'll have 4. But afterwards, we'll have more networking and ways to connect and things like that. So if you're online, share those LinkedIns and Twitters and whatnot and connect. Just be respectful about it. We'll be monitoring the chat and all that good stuff. But in person, I think the floor will now open, and our first speaker, Ron, will come up and start presenting. Ron. Yeah, are you still installing it? Oh, Dennis, you want to open then? Yeah. So Ron, we'll have you go third. All right. So we're switching the order now. Dennis Garcia will be our first speaker.
All right. Let me get connected. Give me a second. Sorry about that. All right. So while I'm waiting on that, I do have a joke. Believe it or not. And I've been waiting to do this one for the longest time. I think I might not even know where I'm going with this. Why did the Java developer wear glasses? Why? Yeah, because he couldn't see sharp. Okay, we're good to go. All right, so can everyone hear me online too? We good? Okay. All right, so my name is Dennis, and for y'all who don't know me, I'm one of the admins here, like Danny mentioned. I'm a senior software engineer with a company called the Imagine Group. That's a commercial printing company based out in Minnesota. And yeah, so my current weapons of choice right now are C# and SQL, and lately a lot of React. And that's not the way it kind of started. It kind of started actually doing a lot of JavaScript and then progressed into Angular and been doing React for about 3 years now. So today's talk, I do want to give a presentation about what design patterns are. And design patterns can actually be used in many cases. They can be used in Java, they can be used in TypeScript, and they can be used in C#. So just don't feel like this is a .NET night that you're not going to gain some knowledge here. So we're going to start working on design patterns. And first of all, I kind of want to get an idea of who's heard of design patterns. All right, everybody. Now, who's actually used a design pattern? Oh, that's a lot of people. Okay, so I'm just going to kind of give a small brief, I guess, history of what design patterns are. And I think I'm doing the wrong screen here. There we go. All right. So design patterns were first established by software programming developers who wanted to take documentation to a whole new level. They wanted to solve the most reoccurring problems of creating software. And the interesting part about this is actually they drew their inspiration from another person. And his name was Christopher Alexander, who came out with a book called A Pattern Language. Has anybody heard of this book? Okay, so the pattern language is actually, oops, darn it. Darn mouse is trackpad. So the pattern language is what these four developers kind of drew their inspirations from. And one of the things that Christopher Alexander did is that he drew his inspiration as well from medieval cities. He noted the reason why they were so prosperous was because of how they were built to local regulations that require specific features, but free the architect to adapt them to certain situations. Now, a sample of this, and I kind of want to just kind of do a little quick, I guess, hands-free thing. If you will, just kind of imagine drawing a house, you know, from with a piece of paper. What would that house look like? And I kind of, everybody saw it already. The house is going to probably look like this right here. So it's going to have something similar to this. It's going to have windows, it's going to have a door and a roof. And something that Alexander thought about too is that this is kind of how the structure of houses are, right? And it makes a house a home. And that's kind of what he describes in his book, A Pattern Language. And to make this even more comical, I guess, is that if you see a house, you know, the one I think about usually is this one right here. And who knows who this house is? Simpsons, right? So this is the Simpsons house, but you know, it still follows the same design pattern where it kind of has windows, a door, and a roof. And so even though that Christopher Alexander was talking about houses and buildings, the same thing can still be applied to object-oriented software. So a quote from Christopher Alexander is, "Each pattern describes a problem which occurs over and over again in our environment, and then describes the core of the solution to that problem in such a way that you can use the solution a million times over without ever doing the same way twice." Now, if we think of the house illustration, we can see similar designs, but still at different settings and still feel like a house. Oops, I am bad with this mouse. Trackpad. I'm gonna bring my mouse. So the solution for these design patterns are expressed in terms of objects and interfaces instead of walls and doors. But at the core of both kinds of patterns is a solution in context. Now, who's seen this book before? All right, so this is the origin story of software design patterns right here. And there were 4 developers, these guys who came up with the book, Eric, John, Ralph, and Richard. And it was called Design Patterns, Elements of Reusable Object-Oriented Software. Today it's known as the Gang of 4 book or GOF book. So this book features 23 patterns solving various problems of object-oriented design and are grouped in 3 different classifications. These classifications are creational, structural, and behavioral. Now, the creational work on creating objects, structural works on assembling objects and classes into larger structures while keeping these structures flexible and efficient. Behavioral patterns focus on effective communication and the assignment of responsibility between objects. And to put these under their correct classifications, here are the design patterns that the Gang of 4 originally came out with. As you can see, there's about 5 under creational, 6, 7 under structural, and the rest are under behavioral. Now, even though this book was published in 1994, most of these patterns are still used today and have inspired many other patterns as well, such as dependency injection, repository pattern, unit of work, CQRS, specification pattern, and many, many more. There's also another part of patterns called the anti-patterns. And interesting enough, there are a few of the original patterns that blur between being an anti-pattern and a normal pattern. So with more than 30 design patterns to date, how do we select a design pattern? Well, consider how design patterns solve a design problem. Design patterns can help you find appropriate objects determine object granularity, and specify objects interfaces. Next, we want to look for the intent of the pattern. We want to read through each pattern's intent to find out one or more that sounds relevant to the problem you're trying to solve. And sometimes it might just not be one, it might be multiple patterns that you want to use. So next, we want to examine a cause for redesign and then look at patterns that might help you want to avoid that redesign. Consider what should be variables in your design. The focus here is on encapsulating the concept that varies, a theme of many design patterns. Now, once you pick your design pattern, how do you use it? Well, there's a lot of sample code out there. So if you want to grab one of those and kind of just put it together in a .NET application, you're more than welcome. Or if you're not using .NET, Java, or whatever have you. Next is understand the classes and objects and the pattern and how they relate to one another. Choose names for the pattern participants that are meaningful in the application context. For example, if you're using a logger and you want to create a factory pattern, perhaps naming it as logger factory would be a good naming convention for it. And no talk would be complete without saying how we should not use design patterns. Often design patterns achieve flexibility by introducing additional levels of indirection and can complicate a design or cost some performance as well. A design pattern should only be applied when the flexibility affords is actually needed. Now, so avoid the shiny new anti-pattern and don't use it everywhere. And just remember, keep it simple and straightforward. So I do want to go over a couple of design patterns since there are 23. If we go over all 23 plus more, I'll be here all night. But before we do that, let's go over some key terms. Has anyone heard of a UML? Okay, so have you used the UML to structure your classes together? No? So a UML is actually one way we can show object relationships. A class can be represented as a rectangle with the class name in bold. Attributes and data types appear in normal type font below the class name, and any operations that we can operate on are below that. Now we need a way to connect these together because we just can't have a bunch of random boxes out in places. Therefore, we have to have a definition for arrow types. So you can see that the plain arrow indicates a class keeps a reference to an instance of another class. The open arrow, which is the open triangle, indicates a class inheritance. The dashed arrow indicates a class that instantates objects of another class, and the arrow points in the class of the instantated objects. The plain arrow with diamond indicates aggregation, and aggregation implies that one object owns or is responsible for another object. So let's dive into our first pattern here, the factory pattern. The factory method design pattern defines an interface for creating an object, but lets subclasses decide which class to instantate. This pattern lets a class defer instantation to subclasses. Now, going over the diagram, we can break down by identifying the key players in this pattern, which is the product. The product defines the interface of objects the factory method creates. And I am doing that again. And the concrete product implements the product interface. The creator declares the factory method, and the concrete creator overrides the factory method to return an instance of a concrete product. So this is building objects, correct? So if we were to put this under a classification, what classification would that be under? Anybody? Creational. Okay, cool. Thank you. All right, the next one is the strategy pattern. The strategy design pattern defines a family of algorithms, encapsulates each one, and makes them interchangeable. This pattern lets algorithms vary independently from clients that use it. And to go under the players for this one, we have the context, which is the where it's configured for the concrete strategy object. And the concrete strategy implements the algorithm using the strategy interface. And then we have strategy, which declares an interface common to all supported algorithms. And there's this reason why I did pick these two, which we'll go into the examples when we get there. So let's kind of go and understand how patterns do work together and look at an example of that by looking at MVC. Now, MVC is not really related to .NET, but it is what its inspiration came from, is this pattern here. This pattern is how it's a group of patterns working together. And the first relationship you can see is the view controller relationship, which is an example of the strategy design pattern. The model view is an example of an observer design pattern and how we can decouple objects so that changes to one can affect any number of others without requiring the changed object to know the details of the other. And to go into more newer patterns is that we have the repository and the unit of work pattern. The repository pattern and the unit of work are intended to create an abstraction layer between the data access layer and the business logic layer of the application. And this helps a lot with test-driven development. Now, there is debate on whether using the repository pattern with the unit of work is just another abstraction layer over entity framework, which is actually using it under the hood as well. But the best thing about this is it does give you the flexibility to use unit testing. And one of the last patterns I do want to discuss is dependency injection pattern. Dependency injection is a design pattern used to implement IOC. Do y'all know what IOC is? Inversion of control. Thank you. It allows the creation of independent objects outside of a class and provides those objects to a class through different ways. Dependency injection is, one of those key terms that you hear it a lot, but it's a very simple thing. It's just basically you're injecting a class into another class. And looking at the dependency injection diagram, you can see this. The injector class creates an object of the service class and injects that object to a client object. So there are some resources that help me put this presentation together. The first one is deviq.com. It's a great site. DoFactory.com is another one for .NET. So if you want to know how .NET, and this gives perfect examples of how to use design patterns. The refactoring.guru also gives another example of how to use design patterns. And if you want to see how these design patterns are used in the wild, may I suggest going and Googling eShop Web. And there is a GitHub right there for that. It's .NET-architects/eShop Web. Gives good examples on there and how you can see specification pattern being used and various other patterns as well. So now, code examples. So let me switch over here. And I'm really bad with these Zoom controls, so give me a second. Going to settings. Okay. And you should stop seeing my screen online, and I'll get that back up and fired up in a second. Give me a second. Share. All right. So here's a project where I'm using the repository pattern, but I didn't start off using the repository pattern. I'm using a bare bones entity framework. And right quick before we dive into that, I want to show you how this is actually using a factory pattern underneath the hood. So if we look at web application and we press F12 to go into it.
That part's not working, but online it is.
Oh, right. So that is not what I wanted. Cookies. Yeah, it had the screen split, but then.
Because this is extended, it's not duplicated.
Right. I might drop off again. Okay, can you still see me online?
Yep.
Cool, thank you.
It's perfect.
Thank you. All right, so web application. If we go into web application, this is actually code behind the scenes that's running an API with .NET. And you can see here that one of the things it's doing is creating an iLogger factory. And then for that, it has a .create logger. Now, the cool thing about this is that it's gonna default to implementing a default logger for .NET, but you can also use dependency injection to start logging different, or use different loggers for it. For example, using a popular logging software is a Serilog. And so slipping back over, again, this is kind of just a bare bones web application, or it's a web API. If I was to run it, give it a second to build. I'm slow on my machine for some reason, don't know why. And while that's building, I'm going to navigate over here to kind of show you deviq.com. And oh, look, it popped up. So here it is, the Swagger documentation that was generated from the API I created. It's a simple thing that shows genres, movies, and ratings. And I can kind of query ratings right here. If I go to try it out, this queries data from my database. And as you can see, the payload is just basic information as ID and rating. But the way this is broken out is using a pattern in itself. I'm going to stop this. Called clean architecture. And in here, I've broken things down for infrastructure and application core. Application core is going to house my entities, and infrastructure is going to where my data context is going to live for entity framework. And if I look at the movies controller, I'm injecting the data context with dependency injection into the movie controller. And getting information, I can now query my database using entity framework. But the problem is here is that we're implementing to a concrete type, or we're passing in a concrete type, and we want to actually pass in an interface. So that's where the repository pattern comes in. So if we flip over to using the repository pattern, we can see that we are passing the repository pattern in now, and my infrastructure changed a little bit. Now I'm actually creating a repository class that defines methods I can now test if I want to get add and delete basic CRUD operations. And then within here, I can inject each repository through an interface now. Now, the thing about this is that I'm going to need to pass in multiple interfaces to implement different repositories. So that's not good. So to make this even better is that what if I could just pass in one interface, which is where the unit of work would come in. So now the unit of work is just passing in one interface into the controller. And I still have all my repositories within that controller. So now when I want to test this controller, it's more flexible, and I can pass in mock unit of work. And going back to my deviq, this has design patterns in here. And if we look at the factory method, I want to look at the strategy. The strategy is what's used to implement dependency injection. So if we look at an example of that, there it is, sorry. We can see something familiar here, as we also have a repository pattern. So this is a repository pattern that implements an interface. So we define the interface right here, and the interface is going to list genres, and it's going to list movies. So this would be our, if we go up to the diagram, this would be our strategy. And then the context for that would be what we're going to implement, which is the actual EF movie repository. And then in here, under the main controller, this is what they call the poor man's way of implementing our dependency injection is they're passing in a new entity framework, but usually, like, for example, .NET, it'll take care of it for you. You don't have to do it. You just pass in an interface, and the interface will instantiate the object for you. And let's see here. And that's what I have. Is there any questions? No questions? All right, that's all I got. Thank you all for having me, and see y'all later. All right, our next speaker is going to be Ron. Ryan. Sorry, I heard an R in there.
Yeah, it worked.
Okay, can online hear me? Looks like they can. Here. Okay, so hello, my name is Ryan Monaghan, and I'm going to be presenting kind of a broad overview of C# and what you can do with it. So the name of my talk is C# from Web to IoT. The agenda for the meeting is I'm going to introduce myself a little bit more. We're going to talk about what is C# and what is .NET. I'll introduce a command line application, a sample API. We'll talk about how you can get .NET on your phones, or if you're already using an application that utilizes .NET. We'll talk about where .NET is used in game design, as well as Internet of Things, and where we can deploy .NET applications. So we have a little burning Elmo. I think it was very appropriate for Dennis's Cookie Monster. So we got a good Sesame Street theme going. So yeah, my name's Ryan Monaghan. I'm a backend software engineer at Evry Healthcare. We're a fully licensed health insurer here in the state of Texas, recently acquired by Globe Life. I have a bachelor's degree in mathematics from UT Dallas, and before I was a developer, I taught high school computer science. I've been using C# professionally for about 5 years now, and it's been a great ride. Some interesting facts about me: I collect fountain pens. I've soldered my own keyboard a couple times. I read math textbooks for fun. And then I'm currently pursuing my master's in computer science at Georgia Tech. If you'd like to connect with me, here's my LinkedIn. I'm happy to connect with anyone here. If you would like a copy of this presentation and any of the code examples I have, they're on my website, and that'll be linked again at the end of the presentation. Okay. So kind of a broad overview, C# is a modern open source and object-oriented programming language. It was first released in 2000. The most current version of it is C# 12. C# is going to be the programming language that we use, whereas .NET is an open source framework and managed software. It's an open source managed framework stack. The current version is .NET 8. You're going to hear some confusion here between .NET Framework, which would be one of the more original versions of .NET. Then we moved to .NET Core, and now they've dropped the core and we're on .NET 8. So when you think of C#, C# is the programming language. This is our Java, where .NET and ASP.NET are going to be your Spring and Spring Boot. To get started programming in C#, all you need to do is download the .NET SDK, and you can find that on Microsoft's website. So with that being said, we're going to go ahead and get started with some code. Learning how to code isn't complete without your first simple hello world. My hello world of choice in .NET is a simple console application. To get started with this, all we have to do is open up a brand new console. Type .NET. Can we make that bigger? Type .NET, new console, give it a name. Hello World v2. You type name as the flag first and then the name. There we go. This is going to do a couple things for us. It's going to create a folder for us. So if I just change the directory to Hello World v2 and open it up in VS Code, we can see that we can use VS Code to make .NET applications. Recently, Microsoft has created a VS Code extension called, I believe it is the C# Dev Kit, which gives us a lot of the features that you're going to find in Visual Studio. So if you guys are more comfortable with VS Code, you can use that tool here in C# land as well. So a simple C# is a simple console app is just console.writeline hello world. It looks a lot like a Python application. And then to run it, all we have to do is make our text bigger, and it's just .NET run hello world. I think that should do it. And it's not a presentation without some errors. So VS Code also does give us the ability just to hit the play button. It'll compile it and then run it for us. So here we go. And we have our hello world. So congratulations, we've written our first C# application. Going back to the presentation. Once again, this creates a few things. It creates a folder for our project. It creates where the command line project is going to live. It creates a solution file, which is basically how C# is going to collect multiple applications or multiple libraries to form a solution. So you can have your database layer like Dennis had, you can have a front end, you can have all sorts of different applications to form a cohesive application in other libraries. So things that I like to use command lines for are simple proof of concepts. If I'm wanting to find out how a new library works, if I want to process local data on files, or create small utility programs. At my company now, I use a simple command line application to help me with USPS address validation. As opposed to having to go to their website and validate if an address is there, I can pass it an Excel file and have it use their API to validate addresses for me. It makes my life so much easier. So C# isn't only on the console, it's also on the web. We can create APIs, we can create SPAs, single page applications using all of the common JavaScript frameworks like Vue, React, and Angular. .NET has Razor Pages, which is their own templating library, as well as Blazor, which is their competitor to JavaScript now. And then, like Dennis said, they also allow for the use of the MVC design pattern. ASP.NET Core is the framework for building applications. This is what gives us the APIs we need to create common web apps. Kestrel is the new name of the new default server for C#. It used to be IIS back when it was only Windows, but now that they have Kestrel, it's a very high performance web server. So as a quick example, C# isn't only, on VS Code or Visual Studio. JetBrains has an IDE called Rider, which is what this is, that allows you to program in there. So if you guys are an IntelliJ fans, for my Java people out there, JetBrains has a solution for you in Rider. So what this is this is a minimal API, which is pretty much a one file program for a simple API where we can map out our different endpoints. So here we have a GET request for weather forecast, just returning a static array. So if we run this, we're going to see a Swagger page right up here. So with the Swagger page, we can go in and actually execute against our API. We see that returns our weather for us, which once again, we can't see because the screen is tiny. So there we go. So back to the presentation. .NET allows us to create mobile applications with .NET MAUI, which is a cross-platform UI framework that lets us use C# code to write mobile apps. With .NET MAUI, you can create both Android and iOS. On iOS, it allows you to use UIKit, Touch ID, ARKit, and then their core ML. So it's a second-class citizen, but it gets treated like a first-class citizen. Here's an example of screenshot of the base template for a .NET MAUI application running on a Android emulator, which you get with Visual Studio. And then, of course, no race car GIF is complete without a cat. While playing games, C# can be utilized, or you can use C# in different game engines such as Unity, Godot, Monoghan, and CryEngine. CryEngine was the game engine that developed Crysis. Unity or C# has been C# is the programming language of choice for City Skylines, Hollow Knight, and Hearthstone are some major examples I was able to find that use C# in the gaming industry. So learning to program in C# gains you the ability to work in a multitude of fields. I guess the piece de resistance of my talk is the Internet of Things. This is kind of where I chose to deep dive. If I can find my USB port. So using Nano Framework, which is a open source controller or a open source framework built on top of .NET, it allows us to deploy C# onto small single board computers. So this is I believe it is a ESP32 board. So it doesn't have an operating system. This is not a Raspberry Pi. It's just a simple thing. It has Wi-Fi and Bluetooth. I was able to set it up to where it would serve me a web page as like a small web server and connect to my Wi-Fi network. Currently, it is running a small application to flash. It's built in a little NeoPixel, and it's just rotating the colors. So we grab the GPIO pin 22, and I'm just having it loop in an infinite loop, changing the colors, from its RGB colors. So, and this is to deploy this is as simple as hitting this run button. It'll build it and then deploy it live to the actual board. And well, if there weren't deployment errors, because of course. So I'm glad I built it beforehand to show you guys that it actually did work at one point in time. But for now, we'll go ahead and move on for the sake of time. Using Nano Framework, they have samples on their GitHub that allow you that show you how to use MQTT, which is a messaging protocol, Bluetooth, Wi-Fi, access the GPIO pins like I've done here if you wanted to hook up different sensors. I2C and SPI are communication platforms if you wanted to have these, set up multiple of these to communicate back and forth or over a double wire, and a lot of other cool things. I think IoT is often overlooked when in the C# ecosystem. And it was, I think, the thing I was most excited about in preparing this talk. Some common myths about .NET. I hear a lot of trash talking about .NET in the Discord, so I wanted to dispel a couple myths. You can only develop for .NET in Visual Studio on Windows. Granted, I am using a Windows machine right here to give this presentation. It's what I am most familiar with, but that is actually false. You can use VS Code with the C# Dev Kit and JetBrains. I've shown you both examples here today. Starting in .NET Core, you're able to deploy to Linux and Mac, so you can program on all three major operating systems. Programs written in C# can only run on Windows. Once again, this is false. In 2016, with the release of .NET Core, C# runs on all major operating systems. .NET is closed source and tightly controlled by the evil Microsoft. Was true at one point in time. They have reined it in with the release of .NET Core. Microsoft has open sourced both the C# language and the .NET framework. It's currently controlled by the .NET Foundation, which is an open nonprofit organization. So if you guys want to contribute to the .NET framework, you're more than welcome to open a PR. And you might get to work with maybe. And then I think another big one is the only cloud option you have is Azure, right? Azure being Microsoft's cloud. Granted, Microsoft would really love you to deploy all your applications to Azure. They make it really simple in Visual Studio, but C# can be deployed to all cloud providers, AWS, GCP, or any other VPS, virtual private server. On AWS, you can run C# code in Lambda functions as well as utilize their CDK, their cloud developer kit, to define infrastructure as code and provision resources through CloudFormation. So AWS is treating C# like a first-class citizen. Something I was really interested in that got released this year was .NET Aspire. And because I have a little bit more time, I'm going to get to squeeze this one in. .NET Aspire is a collection of packages that allows you to build cloud-ready, observable, and distributed systems. Out of the box, .NET Aspire provides a great developer experience with its dashboard, built-in observability with OpenTelemetry, which they've already orchestrated for you, and orchestration, which provides your service discovery. So if any of you guys have worked in a microservice architecture, orchestration and service discovery is a real big pain in the butt. So for Aspire to provide that to you out of the box is just really cool. There are already a lot of pre-built components such as Redis, Apache Kafka, PostgreSQL, SQL Server, and MongoDB, and creating a custom component for whatever small component you need is super easy and very well documented. When I was talking to my team lead that I was giving this talk, he really wanted me to harp that Microsoft's documentation is probably the best in the industry. It makes learning C# and utilizing their tools so easy. So I highly recommend going to learn.microsoft.com and looking to see what they have for you. I do have a quick sample application of .NET Aspire just to show you how cool it is. So with .NET Aspire, this is just their sample application. It's the .NET Starter application. We have a couple things here. We have their app host, which is a brand new package, which ties in all of the other packages. So this is kind of like your orchestration layer. This is where you define what your application is going to do. So here we have a reference to a cache, which is a Redis cache, which I didn't have to set up. It set it up for me with those built-in components. And it has a reference to an API service and their front end, which is, I believe, a Blazor front end. So just by running this one application, it'll spin up all four of these libraries in Docker or Podman. I use Podman, but it'll spin it up in Docker. Give it a few minutes. It's doing the service discovery. I don't have to remember IP addresses or ports. It does it all for me. And then I think what's really cool is just by using .NET Aspire, it gives me this really nifty dashboard. And with this dashboard, I'm able to see what applications I have. I can go and click on the actual link. It'll take me to my application where I have a quick counter. I can hit that weather API I showed you guys earlier where it returns the weather. And since it's already wired up OpenTelemetry, I can go in and look at the traces for my calls. I can go in here and see, wow, this call took 5 seconds. Why did that take 5 seconds? Well, I'm going to go view it. And I can see that it took, Blazor 5 seconds to connect to my backend using distributed tracing, using the OpenTelemetry package. This was released, I believe, only a couple months ago in GA. So this is very hot off the presses, as it were. So it's, I think, the thing I'm most interested in bringing to my company within the next year. So, and then with that, Danny, I'm making your job hard. So with that, a huge thank you to you guys for being here tonight. A huge thank you to my girlfriend for copy editing my presentation. You'll notice the distinct lack of Oxford commas. She's an editor by choice, so while I was giving this presentation to her, it just went all over her head, and she was a huge support in helping me do this. The code for all of these projects is on my GitHub, as well as the presentation. So thank you guys all. Yeah. Nope.
All right, y'all. So I'm going to introduce the next speaker, Ron. Ron is the engineering manager at 7-Eleven.
Good morning, good afternoon, or good evening already. Yes, wherever you are. If you're online, you might be halfway around the world. So good morning, good afternoon, good evening. The length of my presentation today is how long my battery would last. So we'll see how it goes. You see my screen? Good. All right. Okay. My name is Ron DagDag, and I'm an engineering manager at 7-Eleven. Today, I will be talking about crafting an AI mixologist using semantic kernel. A while ago, Jeff was talking about the different .NET, right? The stuff that you can do with .NET. I am using a Mac, and I'll be running .NET in the Mac, so this will be interesting. So this is kind of like an extension of his presentation, talk about what are the other things you can do with .NET too, right? So we're gonna do semantic kernel. Okay, let's start. Today, I'm gonna talk about generative AI. And has anyone here have worked with ChatGPT or have played with ChatGPT or tried it? All right, thank you. And if you haven't, try it out. There's a lot of things you learn. A lot of the technology behind ChatGPT is generative AI. So I'm going to be talking a little bit about generative AI, what are large language models, and then semantic kernel. Semantic kernel, it's how you can create your own chatbot, right? And connect it and create your own generative AI and chatbot. And then what are AI agents and then co-pilots. There's a quote that teaching AI to mix a cocktail is like trying to explain hangover to a toaster. It understands the ingredients, but not the headache. This is a quote from ChatGPT. So I don't know. So today I'm going to talk about AI without the headaches, right? So generative AI is part of broad of artificial intelligence. Artificial intelligence started back in 1956. And then, of course, 1997 is when we start learning more about machine learning, right? Machine learning that enables machine to learn from existing data. Actually, my first introduction to machine learning, I was doing neural network back in 1999. And I was looking at it. And one of my projects when I was looking at it was actually agents, AI agents. I started interesting about this AI agents. I was like, no, I don't think, because the computers back then was like really, really slow and how it was trained. And it's all theoretical. But nowadays, with the 2017, we start seeing about the deep learning and how you can use machine learning or neural networks now to process data and make decisions. Now, 2021, when we start hearing about generative AI, and it's giving us these capabilities of all these. So AI has been here for a while, but of course, with all the new technologies coming in, it's getting better and better. And the whole idea here is that it used to be traditional model development. It takes a long time it's very expensive. It's really very slow to develop. Because let's say if you're doing a classification model, you're trying to do hot dog or not hot dog kind of thing, right? You need tagged data, or you need certain models that you can build on each one of these. So if you're doing detection, or you're doing classification or sentiment analysis, there's a lot of different sets of data in order to accomplish this. So that kind of changes once we start hearing about this, what we call foundation model. These foundation models are actually trained with text, images, speech, into building this transformer model that can be adapted to question and answering, sentiment analysis, and all these. It becomes more generic for us that it can be used for different tasks. So large language model, how it works is that you have an input, like, if you use ChatGPT, you have this text, right? And then it would actually get converted to tokens. And these tokens would be fed into this model, and then it will do this probability distribution to get the language input. So typically, n tokens in and 1 token out. What typically happens. It's actually, what it's doing, it's predicting the next text, right? So has anyone used autocomplete, right? It's kind of like that, right? So generative AI, this large language model, it's kind of like a more complex autocomplete, right? So here's one example. Is 1 tequila, 2 tequila, 3 tequila? What is it? Floor, right? Floor. So we all know that, of course, because, we taught it, right? That it is that. So it's a probability distribution of what is the next word. And it completes that cycle. It's just guesses the next word, and then what's after that, and so on, I think, until it gets completed, right? So if OpenAI is one of the premier examples of this, where ChatGPT is, but notice how whenever we talk about tokens, notice how it's split into separate. It's how these systems work, right? It's not the usual word by word, but notice how the different colors actually is how it's kind of split. So depending on the complexity, or depending on the language, the large language model that you're using, you might need different types of tokenizer. So and usually that's how ChatGPT charges you whenever they use their APIs, or how you communicate. So now I'm going to talk about semantic kernel. Semantic kernel is a lightweight SDK. So it's also it's a .NET library that you can use in order to mix code with large language model. So it's not just create your .NET application. Now you're adding large language model into your application. So it supports OpenAI, also in Azure OpenAI. C#, you can use it for C#, but also Python and Java. And it allows you to be able to combine prompts with that performs action. So some key components of it is, one is it kernel. Kernel is the one that orchestrates users that ask the goal. Then there's the planner, plugins, memories. So there's different concepts in all these. But what I wanted to show you tonight is a little bit more about, what the two goals of what you can use for semantic kernel. There's semantic completion and then semantic similarity. Semantic completion is more like on the prompt engineering side, where you're trying to we're trying to instruct the computer or trying to coach to create an agent to be able to estimate the next completion, just like I was. And then there's the semantic similarity, where you can use it to search the distance between meanings and phrases and documents. So a lot of whenever you're working with kind of like your own chatbot, or you're creating your own and using this large language models, you always think about semantic completion and then semantic similarity. So let me talk a little bit about AI agents, and then I'll drop into different parts of the code. So agents have spectrum, from simple to automated, right? So agents, kind of like chatbot, it's a simple back and forth chat with your users. And then there's what we call the concept of RAG, which is a retrieval augmented generation, which is you have an existing, let's say, a PDF file, and you want to be able to talk, and the large language model can only reference that text or that document. So that's what typically happens on a RAG, or something that you can build the context around. And then there's copilots. Has anyone heard of copilots? Most likely, if you have a Windows machine, you've seen all these copilots. Windows is kind of like selling Copilot everywhere. But of course, there's GitHub copilots and then all these different copilots. What does it really mean, right? What is a copilot? Copilots are a type of agents that work side by side with the user to complete a task. It asks you, like, do you want to do this kind of thing? Or it responds back and it confirms before it actually does the action. So there's actually ways on how you can do this, but it's a kind of chatbot, but it's more advanced chatbot because of the spectrum, right? Because it's, at the end of the day, it's also context aware. So if you use the one on Windows, it kind of knows, hey, who's logged in, and where you're at on Windows, what screen you're seeing. It kind of knows the context. At the end of the day, whenever you think about agents and all these copilots, I want you to think about context. It changes the way the user interface is. So if you're doing web and all these, and why are we having all these chatbots and starting to integrate chatbots into some of these applications? It's all because instead of like trying to find the save button or trying to find all these commands, maybe we can just tell the computer, right? You can tell the chatbot, it knows the context, what I'm at and what I'm doing, and it knows how to execute that command. So it reduces that friction between the user. So that's where the Copilot comes from. And then there's the fully autonomous one, where agents can respond with a stimuli and with human intervention. The way I kind of see it is like maybe self-driving car, right? You say, take me somewhere, and then it would just drive, and it knows how to do, and hopefully it'll be safe. But but that's too far off, right? But we know we have chatbot, we have RAG, and we have Copilot. We can implement now and integrate with our application. So it's very different. In order to build an agent, there's three things that you have to think about. There's plugins where you can give your agent some skills, right? So what it can do, what can it accomplish? And then there's planners, and like it figures out the guidance for your agent, meaning step-by-step instructions, kind of builds like, where to go first, the second, and the third one. And then there's a persona. How do you want to make it like how do you want to make it sound like whenever it converses with another, with the user? So those are the three building blocks of an agent. So whenever we talk about RAG, right? Retrieval Augmented Generation. So one thing to think about is you have a question, and then you have a retriever or something that would search or would know, would plan, okay, what are the things I need to call to get the context? At the end of the day, context, context, context. It's very important in any chatbot. Where do you get the data, right? Where do you get the data? And all that data that you pull in, you pass it to this large language model. And what does the large language model do? Well, it's a good summarizer, or it's a good, Q&A bot, right? You can use it now to be able to say, I have all these context. I know what to do with it. So it knows, it limits the capabilities of the large language model so that it will produce a correct response. So that is the goal there. Okay, it's clear. So I know I went through a lot of these different, what you call these different words, right? Different, but let's start with looking at code. Show me the code. How do you use this? How do you use this in .NET? I think that's more important. Okay, you ready? Yes? Okay, good. Okay, so we'll start with this. Make it bigger. So I have this project, and .NET, I just wanted to showcase this. .NET is not just command line. It's not just browser, right? It's not just browser based. It's not just, creating an app or what you call these, a mobile app. You can actually run it also in a Python notebook in Visual Studio. So this is another way you can actually work with a .NET program, right? Using a Python notebook. Has anyone heard of Python notebook? Or if you're a data scientist or you've tried it, most likely you've heard of Python notebook. But it's kind of like having a notebook where you can run code and then it would respond back. So it's a quick feedback rather than debugging, go through each one of the lines. Like for example, here, I can say, I can run all these code, right? Or I can just say, since I'm doing demo, it really makes it easier for me to do demo. I can do shift return, it executes that line of code, and then it will give me some feedback. So for example, here, these are some settings that I'm doing, and then these are the response that it's saying. And then of course, there's text that you can see, so you can actually follow through what I'm doing here, and then you can start running it. So in order to use OpenAI has an API that you can sign up for, and you can use their API through semantic kernel. So that is one way. So of course, an API is more, there's a REST response, right? The request, but semantic kernel allows you to do more than just calling the API itself, okay? So I have some settings here, but I wanted to show you a simple chatbot, the simplest one. So in order to use semantic kernel, you have NuGet packages. These are kind of like NPM packages for .NET. This one is using semantic kernel 1.16, which is the latest version. So it is installed the packages. And this one, I'm going to create this builder. This builder allows me to be able to create this kernel. And then the kernel is the one that would have me create this plugin. Okay, this plugin. And then this allows me to, for example, I have this plugin right here. And this plugin, what we're looking at is a cocktail plugin. So here, and there's two texts that you need in order to do this, right? The settings and how you would call OpenAI, and also the prompt. Has anyone heard of prompt engineering? Whenever they have prompt engineering, it's kind of like learning how to talk to ChatGPT or how to do instructions. So in this case, these are like kind of like the pre-instructions of how you would send to the large language model, to OpenAI. And then you'll be able to execute. So for example, I'm running this drink joke. So why did the daiquiri break up with the margarita because it couldn't handle the salt anymore. Okay, so so it called the API and it responded back, and that was the joke that it did. Okay, here's another one. So what can you do with this thing, right? So semantic kernel, you can actually use it to, for example, this is my prompt in prompt engineering, summarize the content above in 3 sentences and sound like a drunk pirate. See, there's the persona there, the personality of my bot. And then I can execute it. This one kind of does the setup. And then I call the summary function where it passes it the prompt, right? And then how you would want to execute it. And then here's my text, okay? Here's my text. And I want it to summarize it and sound like a drunk pirate. So let's see how it goes. So in this case, see how it's gonna run. There you go. There's the summary. Our matey cocktails. See, notice how it's what you can use this for. It's combining code plus how you would call ChatGPT. What is this? Why would you want to use this, right, into your application? There are things that you want to be able to, like, for example, summarize certain text, respond back, and then you can have that as part of your application, right? Integrated as part of your application. So for example, you can actually make a trivia. You can actually, based from that text, you can say, create bullet points to fund trivia guide about the text that I just passed in or about that story. So it kind of summarizes it in a different way. And also you can do TLDR, right? So just what is that long document in 5 funny words? Cocktail history, booze, ice, drama. There you go. That's all you need to know about that document. You see where I'm getting at? There's things that might help the user to kind of reduce the workload that they may have to do, and how you can integrate that to your existing application. That's how you can use it for. On this one, so this one, there's in semantic kernel, there's a lot of ways. And of course, ChatGPT does not know what today is, or large language model does not know, like, for example, the current events, because it's trained for previous events, right? Maybe it's trained from last year's data or before last year's data. So it does not know current events. So it does not know the day. So what is today? So for example, today is Sunday, October 24th, 2021. That's a day that it knows, but you can actually, semantic kernel has a library where you can pass in the time of the day, and then it'll be able to kind of figure out like where you're at that time of the day, and then be able to say, hey, today's Tuesday. So let's see if we can run this. So just to show you. Okay. Let's see. So the interesting thing about running it in Python notebook, you can just easily restart it, add it back. Today is Monday. And then notice how it says now today is Tuesday. And then there's also these plugins. Plugins allows it to be able to have capabilities. And so you can actually say, okay, well, answer the following question in JSON syntax. And, give me a good drink. What's a good cocktail for the current time of the day? So today is Tuesday, July 23rd. It's 8:30 p.m. And let's see what it comes up with. Well, it returns it as JSON file, right? With the current day. And it knows that it's not a weekend, it's evening, and mojito. Okay, so when you get home, mojitos is what you need at the moment. But notice how it's had that capability. I don't have to write the special logic. It's like, is it a weekend or not weekend? I can just say, hey, is it a weekend or not? You give it the prompt, kind of like a example of what you're wanting to do, and it kind of figures out, hey, I need to answer it this way and format it to a JSON file. So there you go. That's another capability that you can start using it to. Okay, I'm gonna move a little bit further on here. You can also use DALL-E. DALL-E is for generating images, so you can actually create your own and set up different images, or have generative AI to create these images for you. So I'm not gonna go through the code, but this one is like, think of a cocktail to this time of day with the current day, and then see if what'll come up. So you can pass that in this text, right, this prompt to DALL-E, and then it would return you an image. So in this case, it returned this image over here, right? So it returned that image, and then also it gave the description of that image, what it did. So you can do that. There's also a way so GPT-4o is you can also pass images, right? You can pass images to OpenAI, or if you're using GPT-4o, right? You can pass that, call the API. In this case, I pass this image, and then I ask it, you are a mixologist and a friendly assistant, okay? So that is the prompt for that user. And then I passed in the image, the URI or the image itself. I pass the text content, identify what what cocktail is in the image below, and I pass the image, and then the respond back is like the image is a blue Hawaiian. You get what I'm saying? So you can actually describe what it's seeing, what image it is seeing, calling these APIs. So that's one of the use case and how you can use these utilities. That makes sense. Isn't it interesting? So it kind of changes the way you do some programming, because yes, programming, you have to be like concise, right? Like a calculator, you have boom, 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 right? For these utilities for OpenAI or it's a generative AI, you can use it for stuff that you can, for example, describing an image or being able to do sentiment analysis, stuff that might be able to summarize things. So not just that, you can also, like in this case, you can actually create embeddings or memory to where I can create what we call semantic comparison. So this one, I have a SQLite memory store where it can create an index, right? And then what this one would do is you can create your own kind of like a search engine, right? A small search engine into to this SQL store, SQLite memory store, but you can use it as so you can use it to where you can do embedding search. Embedding search or vector search, right, allows you to be able to do semantic similarity. So if, let's say I want to, so like in this case, I wanted to get, let's see, a list of good cocktails, right? And then it would search my database about, sparkling cocktails. I didn't specify what type, or I just said sparkling cocktails. It kind of know which ones are sparkling cocktails, and then it would return back those values. So for example, here I search the word gin. It search the database for the semantic to all the things that has gin on it, and then I pass it to this chatbot where it would give information, and then it would, let's see, and then it would just respond back. So what I would to show you today is more about multi-agents and where this technology is going. Multi-agents allows you to be able to, right, to create these. So in this case, I have 3 agents, right? One is a program manager, one is a software engineer, and one is a project engineer. The program manager, this is the prompt, this is the engineering prompt. Okay, the prompt here, it says, you are a program manager, which takes requirements, and then for creating an app, the program manager understands the user requirements and the form detail of documents that require the requirements and costing. That is one agent, that's the instruction that you say on this agent. And then there's this software engineer. The software engineer, the goal of this software engineer is to create a web app using an HTML and JavaScript by taking all the considerations, requirements by the program manager. So the program manager is there. And then you have a project manager, which will review the software engineering code to make sure that all the requirements are completed. You are the guardian of quality, ensuring the final product meets specification and receives green light for release. And once the client requirements are completed, you can approve the request by responding approve. So I'm going to create 3 agents, okay? Does that sound like a real life scenario, right? Does that sound familiar of stuff that so this is how you create all these agents, right? The chat completion agent, okay? So you have a program manager agent, software engineering agent, and the project engineering agent, okay? And then now there's the approval termination technology. How do we know when these agents stops at some point, right? Some point, someone have to say approve. So this one is looking at, it would terminate when it sees the word approve, okay? So I have an agent group chat. So agents can start talking to each other to be able to execute something, and then it would only terminate when it sees the approval, the approve text on the chat, okay? So I'm talking to the chatbot now. I want to develop an app which will provide me a selection of common cocktails, keep it very simple, and get the final approval from manager. That is the instruction that I passed to these agents, okay? And then I will loop through, and that's it. That's pretty much the code itself. And it would loop through the chat itself and the conversation between these agents. So the user says, I want to develop the app. And of course, there is the project manager is listening. Well, the first thing is actually the program manager says, great, let's outline the project plan. And this is the agent's. So it created the project overview, what it's supposed to do, the core features of the app that needs to be built, okay? And there's a search functionality, there's a detail screen, there's the technical requirements. Well, I don't know, it did say, hey, let's do this in Android and iOS, and had to be Google Play Store, those kind of things, right? So it developed this plan. So we have a planner, okay? There's a resource allocation, kind of talk about, hey, there's 10 hours a week, there's a UX, kind of like building up the timeline, the cost estimate, how much the thing's going to cost, and then the final approval. So that was the response from the program manager, okay? And then it instructs, please review the proposed plan to get the final approval from a manager. Now the software engineering agent heard it. It's like, hey, the program manager said something. I got to do something about it. So the software engineering agent says, sure, let's follow the plan, create a simple web application, use plain HTML and JavaScript, that kind of thing. It started, sure enough, writing up HTML code over here. It started building up HTML code. And like, hey, that looks right. I don't know. I didn't test this, but this is in just one chat and one instruction. So it created the code, created the JavaScript file that kind of have, what the images would look like, the instructions, kind of come up with different cocktails as a selection. So it spit out something, right? And done some application, done some explanation, then the final step and then on here, the final step, please review simple web application prototype, okay? So the software engineering manager says, okay, I have a software. And then now the project manager agent, sure enough, saw that, hey, there's a program, there's a new software, and then it read it and it hit approve. Interesting, right? Cool. So that's it. That is interesting. Okay. So let's go back to the presentation. I wanted to skip to the last page because so just to summarize what we talked about today, we have generative AI, which is flexible and reusable model. We have semantic kernel. We talk about large language models, and then AI agents and copilots. And thank you very much, everyone. That is my presentation. If you want to contact me today, or you want to get the source, connect me through LinkedIn, and if you can give me feedback about my presentation, feel free to do that. Thank you very much.
All right, still connected here? Yeah, okay, perfect. So our last speaker, Nick, is joining us. So Nick will be taking the floor, Principal Software Engineer at Microsoft.
All right. Cool, okay. So I'm gonna be talking about building plugin architectures in .NET. And I guess a little disclaimer, I'm going to be talking about .NET things, but you can apply these concepts to things totally outside of .NET. There will be some .NET specific stuff as we go through it though. And now I see what people mean with the mouse, okay. Okay, so a little overview. I'm going to talk about who I am, what I do, talk about some scenarios for plugin architectures and why you might want to consider them. Another disclaimer, I'm not trying to force you down the path of using plugin architectures. There's tons of different options. I just like using them. That was weird. I'll talk about tools, patterns, and best practices that I've adopted over time. We'll talk about the trade-offs and gotchas because everything has pros and cons in software engineering. And then if there's a little bit of time at the end, I'll talk about some history about different plugin architectures I've used and different products I built using plugin architectures. Okay, so I am Nick Cosentino. I'm a principal software engineering manager at Microsoft. That's a picture of my wife and I. We got married about a year ago, so our anniversary is very close. This is a mental note to not forget. We have 3 dogs. There's 2 of them. Those 2 are mine. That's Elila and Loki. They're a hoot. We live in Seattle, so we are originally from the Toronto area. We moved out there when I got my job at Microsoft, so I've been there for about 4 years now. And so within Microsoft, for a little bit of background, I work in an area that's called Substrate. And Substrate is the infrastructure that all of the Office 365 services are built on top of. So there's many teams inside of Substrate. It's not just like me and a couple people on the team that are Substrate. It's like there's hundreds of microservices. There's lots of stuff going on. So originally at Microsoft, I was hired on to be the engineering manager for 2 of the deployment teams that we have there. So I spent about 3 years doing deployments for hundreds of services to hundreds of thousands of machines across the planet, which is pretty cool. Just the scale is like kind of ridiculous. And now I am one of the managers this was from the beginning of the year, one of the managers for like our routing plane inside of Substrate. So responsible now for handling trillions of requests per day, whether they're coming from the outside, like the internet into our services, or all of the microservices and stuff communicating with each other. So I own part of that is the web application firewall and some other routing capabilities. So before the big tech kind of stuff, I worked at a company called Magnet Forensics. Was probably employee number 8 there and worked there for about 8 years, which is a really cool experience because they grew to a point where they IPO'd. They got bought back to private for like $2 billion. So a really cool journey to go from like, hey, we're a scrappy startup to, hey, we've kind of conquered digital forensics. So yeah, that was a really cool experience getting to work kind of scrappy startup. I got to be responsible for building a lot of like prototypes for things, turning them into full-fledged products. So had a lot of autonomy. And then more recently, so just under 2 years ago, I kind of said, hey, I want to start making content online, help other software engineers. I actually started this about 10 years ago and gave up really fast. I was like, no one reads my blogs. Why am I doing this? And then convinced myself to do it again. Not really sure why, but it's been fun. I don't regret it. So it was great. I got to connect with Danny and he said, hey, just so you know, like we're not paying the speakers to come out. I said, don't worry, like not a big deal because now that I'm really big on YouTube, I make about well, about $2 a day on a good day. So definitely fronting this with the YouTube side of things. Don't quit your day job for YouTube. But it's fun. So it's been really cool to be able to create content, and that's one of the reasons why I'm here, to help share other information. Okay, that's me. Plugin architectures. Let's go. I want to start with a microphone coming back. No worries. Testing robot voice. Okay. Cool. So I want to walk through some scenarios because I feel like if we can paint a picture for where you might have already seen plugin architectures. The last presentation, we got to see some plugin architecture coming up with some AI stuff, which is really cool. These are super basic examples, but let's think about a command line application. You want to convert pictures, right? You have bitmaps and PNGs you can convert, and you're like, hey, well, this is cool, but I want to convert JPEGs and WebP pictures. You can start to extend your application with plugins. And you can do the same thing with other media, whatever. It doesn't just have to be pictures, just really basic concepts here. Web APIs, if you're building an ASP.NET Core, you could consider building your web application where you have different endpoints that are kind of structured like plugins. So in this scenario, let's pretend that you are a developer. Your product owner said, build out these endpoints. You're like, yeah, I did it. Awesome. I'm done. And they go, wait, just kidding. We got one more thing. And they lay on you like, hey, we got to build out this other functionality. And you're like, oh, crap. Okay, I got to do this now. And you can go build out this next piece of functionality entirely as a plugin and not disrupt the rest of your application, which is pretty powerful. Desktop applications. Yes, people still do build desktop-based applications. At the forensic company I worked at, people were actually afraid to go to the cloud because they're like, we have really sensitive information. Don't you dare put stuff in the cloud. And we're like, you just come on, you got to get there. But we built WinForms and WPF applications for many years. I don't know. I'm sure now they're convincing customers slowly to move ahead. But let's think about Visual Studio, right? We saw Visual Studio Code today. Think about those applications and the core functionality they have. And then some of the pieces of functionality, they just seem like they're whole dedicated, like, workflows that they have. You can drop those types of things in as plugins, which is very powerful. And one other thought I kind of want to leave you with on that part is, like, who's building the plugins, right? You might have people, part of your team building the software that are building those plugins, but you might have third-party people that are also building plugins and customers, and you might have a community around building plugins. And that's a whole different world of trying to support that versus internal development. So something to think about. And the final one I put on here, because I think a lot of people start this way. They're like, hey, I want to be a programmer because I want to make video games. I know for myself and probably other people in the room, it's like, I'm going to go build the next World of Warcraft. Spoiler alert, you're not. But it's fun to start. And I think that you can learn a lot from doing it. And one such thing that you can learn is as you build, you get to a point where you're like, I need to put in more content to the game, or I need new functionality, and you can extend these things with plugins. Okay, so the core pieces about plugin architectures I want to talk about are really these four, I don't know if you call them principles or characteristics, I guess, but modularity and isolation, extensibility, flexibility, reusability, and testability. And then I kind of just put at the end, like, this kind of thing can really put you down this rabbit hole of levels and layers of abstraction, adding complexity. It's very easy to say, hey, look, we could go build a plugin architecture for this thing that totally does not need a plugin architecture just because it feels good to kind of do it. I'm sure some people have done similar things like this. I've had plugins that have plugins that have plugins, and I'm like, why am I doing this? But you have to remind yourself, like, to kind of get out of the rabbit hole. But there's a lot of power that comes with them. And I think that's why I can make it look like it's a hammer that fits every, scenario for a tool. So on modularity and isolation, I do have some pictures coming up too. I tried to layer in some pictures. They're terrible pictures, but I hope they help explain some concepts as I go. Low coupling, high cohesion. I feel like a lot of people in the room have probably heard this idea before. When you're building plugins, you have this opportunity to have highly cohesive areas of code. You're building things for a purpose in one area, but you get low coupling because you can have these things detached from the other parts of your application. And we can do this with physical boundaries. And this is kind of a weird thing to say, because when I say physical boundaries in software, I don't mean like you literally built up a brick wall on your desk. I mean, in .NET land, we have project files and DLLs. These are the air quotes physical boundaries I'm talking about. So you have constructs that you can put in place so that you have this separation. I wrote here, like ideally, you can kind of do whatever you want. I don't write your code for you, but ideally plugins don't reach into other plugins. You treat them like silos. If you need functionality from different plugins inside of other plugins, there's ways that you can pass that functionality around, and we'll see that in a little bit. And maybe by show of hands in the room, I can't see the chat online as I'm presenting, but has anyone heard of vertical slice architecture? Cool, some hands up. What about just like developing with vertical slices, not architecture specific? No? Okay. Same idea. I think a lot of people jump to the architecture part because it sounds like sexy. It's like, we got architectures for this and that, but vertical slice is really just talk about delivering a feature end to end. UI parts, you have your API calls, depending on what you're building, database stuff, depending on what you're building, but it's top to bottom to top, done. That's a vertical slice. You don't say, oh, we want to build these 3 features. It's going to take, 3 months to get the database built. And then we have the database done, but now we don't have the business logic. That's another 2 months. So you can do these things in slices. So there's architecture for that. And personally, I find that when you're building plugins, you can correlate these things with vertical slice architecture and vertical slice development. Not the exact same thing, but they can go hand in hand. Okay, here's my first terrible picture. So this is just an example of having an ASP.NET Core app. We're going to split out into 4 different plugins for these different capabilities we have here. So the auth stack is, say, one plugin that you might have. I talked about this example of your product owner saying, hey, one more thing, right? So you had the shopping cart, you had the products, and they said, but it's not done until we have reviews. So you could go add a whole plugin that's your review system on top of this, and ideally not be disrupting the rest of your application. In this example, you would have your core app as your main entry point, your primary executable, and then each plugin would be another project. And I'll have some screenshots of some of this stuff coming up so you can see it in Visual Studio. For extensibility and flexibility, I'm going to start talking about some more like specific concepts that come up in plugin architectures. Maybe by show of hands in the room, familiarity with dependency injection? Lots of awesome, great. Familiarity with reflection in C#. Also, that's sweet. Okay, cool. Oh, I'm done. I'll see you guys later. Yeah, so these things, I think when you're building plugin architectures, I think it's not that you always have to be like on top of them, but I think if you don't have a fundamental understanding, this kind of stuff can get pretty challenging, especially if you're starting it up in the first place. So the first part I'm going to talk about here is assembly scanning and plugin loading. So the idea when you're building plugins is that you ideally do not want to have to change your core application to be loading in extra behavior. You build this stuff separately. You don't have to touch your core application. You can dynamically load the functionality in. You can, and I'm going to have, again, more pictures are coming up in a bit, but you can have the same application and configure it with different plugins. So you could literally go compile stuff once. You might build 4 plugins, 1 core application, and then you say, for one version of this, I'm going to pick plugin 1 and 2, bundle them together. That's one product. And you could go combine plugin 3 and 4 with the core application. That's another whole product. You can mix and match these things, which is really powerful. And then, as I was kind of mentioning from earlier, like when we were going through those examples, you want to be able to think about when you're building your own plugin systems. That's really weird. You want to figure out who is building the plugins, right? Is it your core development team? What does that look like as you're building plugins? Or is it your third-party plugin community building the mods for your game or your Visual Studio extensions, right? The picture is coming up right after this one. It's a doozy. So with reusability, I have 3 scenarios I'm going to walk through. One of them is, let's take, for example, something like Visual Studio. Maybe you have a really simplified version of Visual Studio, which just has a handful of core features, and that's for basic users, and then you might have power users, and you're taking the exact same application and just slamming in 100 more plugins. Here's all these fancy features. It's literally the same like core application though. Example 2, I don't know if the right word for this is something like white labeling. You can see this in other industries. If you're online, what's happening is the projector keeps going in and out, which is funny. So like a supplement industry or vitamins and stuff, this is pretty popular. There's a manufacturer that'll make a product and they go, we have this product, we can slap your brand sticker on it and you can sell it. So I think that's called white labeling. But you can do a similar type of thing in software development where you can say, I'm going to build this system and maybe not just the theme, but maybe some of the functionality. We can swap out the plugins and I can basically take 95% of the work and sell it to a different customer with slightly different features. And the third one I want to talk about in the picture, I'll just jump to it right now, I guess, because it's probably easier with the picture. The third one, which is the far right side of my screen, is taking this same set of plugins, so plugins 1 through 4 in this example, but you're switching the entry point. So it's the exact opposite of the other ones. In this case, the example I'll give is I built some ASP.NET Core web apps. And I go, great, this is cool. And I start debugging things, I'm testing them. And I go, you know, like Postman is good and all, but it would be really cool if I could just like debug this thing on the command line and run some commands. But like I'm in ASP.NET Core, I don't really have that luxury. I could go build a page or something that I could go write commands into, or I could just change the entry point. I can write a very thin console application that just uses my plugins. And now I've changed the entire application. I wouldn't ship that to customers, but I can debug with it. So hopefully with this picture, as beautiful as it is, you can see that you can kind of recombine or repurpose plugins with your core apps to get different things out of them. In this case, in this example, all the code, the colors that you see, that code is the same compiled code, which is what makes this really cool. Okay, testability. I actually forgot I was going to mention at the beginning. So when I was trying to figure out the topic for this conversation, I did a little bit of a social experiment. And I say it's a social experiment because I knew what the answer was going to be before I did it. But I ran a poll on LinkedIn and I said, I have 2 topics that I could present about: plugin architecture or testing. I knew that no one was going to vote for testing because I know no one likes to talk about testing. I know it's boring, but it's really important. And I figured, hey, if I'm going to talk about plugin architecture, I can bring up testing still. So I'm going to sneak it in here. But when we talk about having these modular isolated pieces of code for plugins, what's really cool is that when you're developing a plugin and the physical boundaries we talked about, you can have a lot of confidence that you're not going to go brick the rest of your application. Now, everyone has different development teams for how you're set up, and you might have dedicated testers or QA in your team. You might not. You might be doing that with other developers. You might not have anyone testing anything, and that's okay too, for a little bit. But what's cool about this is you can have conversations about the testability of what you're building. So the example that I wanted to talk about is at that forensic company. I was building a mobile acquisition tool so we could take your phones and pull all the data off of it. It's not as scary as it sounds, I promise. But what we were doing was building plugins that could basically use exploits to take the data off of your phone. And when we were building these things out, I was talking with the test strategist that we had on our team, and I could show him in code. I said, hey, look, that stuff that we built, you were, doing the validation, you saw the tests that we wrote on it. You felt good about that, right? You felt like you have a lot of confidence. Yeah, he's happy with it. I said, all this code that we just built for this new feature does not touch a single line of that code. It's entirely over here now. And I can show you the tests that we have on that. I said, do you feel that you have to go test the other stuff, like to go do regression testing? Or do you feel that the tests we wrote on that other stuff, they're good? Like if they're still passing and I can show you we didn't touch that code, you're good. And he's like, yeah, why would we go do that again? I said, great question. That's awesome. Cool. Let's not retest that. So you can have conversations with people about your confidence level in your changes. And I think this is an undervalued thing depending on, again, your development team. Some people might say, we got to test everything all the time, always. but like, do you? Like, that's why we're putting in automated tests. So if you separate these things out, you can get that capability. The thing that's a bit of a catch is that when we talk about plugins, though, when it comes time for integration, I'm not going to try to press back on this presentation. I don't know what's going to break. But if you remember the pictures about the different plugin configurations, the things that you're going to want to pay extra careful attention to are when you ship that code. Is it the right configuration? Did you forget to add plugin 4? Right? The product owner said, hey, we want that review stuff added. And you said, no problem, I made the plugin. And then you forgot to actually add it into the part that deploys it. Oops, right? Like you got to check for other things when you have plugin systems. So something to think about. Okay, this is just a picture to try and demonstrate, if that product owner was like, go add that review plugin, and you were like, awesome, okay, you don't have to go read this slide in detail. It's the same thing over and over. But like, hey, if we have high confidence in all these other areas, like, and we're adding this new one, we really just have to make sure that this new area is good. We have that isolation, which is nice. Okay, tools, patterns, practices. So I asked already about dependency injection and reflection. There's a lot of hands up, which is great. And again, if you're on the call or you're watching the recorded version of this, these are concepts that I think you probably want to spend some time on, at least dependency injection. That will be highly valuable across, different programming languages and the different things you're going to be building in your career. Reflection's a little bit unique. It's, you can tie it really closely with plugin loading, but these are two things that you're going to want to invest some time into to get some understanding. Specifically, like from my personal experience for frameworks for dependency injection, I really like using AutoFac. AutoFac has been around for a long time. At the time when I started using AutoFac, the built-in iService collection that we see in ASP.NET Core, like if you're building ASP.NET Core web apps, you're probably like, Nick, what the heck is AutoFac? Like we already have dependency injection. At one point, it was terrible. It was so awful to use, and AutoFac was just like 100 years ahead. And now that gap has been like dramatically closed to the point now where I'm building stuff and I'm like, AutoFac's so good, but it feels like no one else is using it. So like I'm fighting against the system. So I'm actually shifting back to iService collection. There's another NuGet package that you can leverage with iService collection. I never know how to say this one, and I hate saying it in YouTube videos. Scrutor. I don't, there's no good way to say it. Scrutor, but it can help with the assembly scanning part, which is on this very next slide. So there are lots of these frameworks, but these are sort of the combinations that I like to use. Okay, so assembly scanning. This is going to be one of the things we have to focus on when we're building plugin systems. Where are you loading the plugins from, and how are you getting the information out of the assemblies that have your plugin data? So you might say, hey, in my running directory, just go load in all the DLLs. Anything that's there, that could be a plugin. Let's go load it. You might have a dedicated plugin folder, or depending on how complex your plugin systems are, you have multiple plugin folders to load from. You could do really fancy things and say, I don't even have a plugin folder. I'm going to connect to a service that's going to stream back assemblies to me, and I'm going to load those assemblies over the wire. I've never built something like that, but I think it would be super cool. So try it out. But assembly scanning is going to talk about which plugins you're working with and how you're getting the actual types out of those assemblies. I did want to mention, well, I guess it's on this next slide. So I'm trying to look at my notes and compare them to the next slide. But so this is a bit of code. It looks pretty terrible. It's some really gross link syntax and some reflection stuff. But I wanted to talk about what this code does. AutoFac is something, like I mentioned, I use it a lot. AutoFac, the way that you primarily leverage AutoFac is if you have a dedicated plugin. I talk with my hands a lot, by the way. So if you have a dedicated plugin, it would have something like a module, and it's an AutoFac concept. The module allows the plugin to define which things it's going to register onto your dependency container. So it gives the plugin full control of what it wants to register, if that makes sense. Now, if we take the concept of Scrutor and some of this assembly scanning code I have on the screen, which is not Scrutor, but sorry if that's confusing. Scrutor does the opposite, where it says, point me to all the assemblies, and I am going to go load up all the types as you define them and I'm going to basically add them to the container. So the plugins themselves don't define like, here's how I would like to be registered. Scooter is just like, there you are, I'm taking you. So the funny thing is, I use AutoFac, and I have all of my plugins always defining how they get registered with modules. But I was like, you know what? I always register them the exact same way. I'm like, every type that's public, just like jam it on the dependency container. And I should add the caveat here that I build plugin systems where I am the developer and my team is the developers, not third-party plugins, because you might have some other considerations if you're just like, hey, anyone, you can just inject any service you want into this. Different things to think about. So this code that we're seeing on the screen, the part that's cut out is which assemblies, or in this case, which DLLs you want to go look at. If you know how to write a for loop over a folder, that's all that's happening before this example. We're going to pull in those assemblies with reflection. And then I just have some link. Can you see my cursor? No, you definitely can't. Okay. I'm not going to point at lines of code with the cursor. The where clause is basically just a really big filter. And this where clause works similar to how Scrutor would go examine assemblies. It basically says, if it can be loaded, go load this thing up. However, you might change your mind and say, Nick, that's kind of a ridiculous thing to do. My plugin only has one interface. It's the iMedia Converter plugin. Just load those things up. And you can totally do that. That's fine. So you have lots of options, but assembly scanning is the part that's going to be controlling how those plugins are loaded for you. So far, so good? I see some nodding. Cool. Excellent. Okay. This one's a pretty quick slide, just something to think about. I think a lot of plugin systems are essentially, so you're compiling plugins ahead of time, but they get dynamically loaded. Where we dynamically load them is usually, for a lot of these situations, at startup. So you're kind of like, well, why would I do that? Why wouldn't I just like compile it all and ship it all? And for total transparency, a lot of the systems I build, I do exactly that. I build it all at the same time. I cheat. I have Visual Studio literally say when I'm building the entry point, just go build all these plugins too. But I like using it for the separation. The reason that I do that is because the other way to do it is that you have them all built separately, which if you're in a big company or you have complex configurations, you might want to do that. But now your deployment and your build system is very complicated because you have to say, hey, I'm building flavor A of this. Now I need some manifest that says to go pull these plugins in from this build and build this part first. Like it balloons out of control really fast. But if you build that stuff out, you have that flexibility. So I generally do stuff at startup. So you're starting up an ASP.NET Core web app. The DLLs are available there. And right at startup, it's like, just go load these plugins. It's done. It's out of the way. Adds a second or two to your startup time. Great. It's done. Now, the other way that you could do this, and I think this is maybe more popular in user interface or user-facing feature scenarios, especially with third-party plugins where someone's like, I'm using Visual Studio and I just want to do this thing, but I need this plugin. Like they might not want to go restart Visual Studio. Spoiler, you do have to do that. So maybe a bad example, but you might have things where you're like, I just want to go take this action. I don't want to spend 10 minutes getting back to where I am. Let me dynamically load it up. So different things to consider for the features that you're building and the plugin systems that you want. This is a weird one to explain, and I didn't draw arrows on here, and I'm not going to be able to use my hands to do this. I'm going to try my best though. I wanted to talk about ownership of who gets to put dependencies onto the dependency container and who gets to read them. So you're going to have to use your imagination here a little bit because there's a lack of arrows, but we're going to look at the top row first. In this variation, what I've done is I've described a core application. I'm just listing out a few core dependencies it might have. Like it's going to be responsible for plugin loading. That's one of its jobs. It's going to define the logger. It's going to define some telemetry stuff, and it's going to set up the database configuration. Now, in this example, all of these capabilities, for lack of a better word, they would be accessible to all of the plugins. So you could go build plugin one, and its dependency container could say, hey, I need to be able to log stuff, right? I am the I need a good example. I'm the bitmap to PNG converter. I need a logger. Okay, so it would ask the dependency container and it would get that information from that core application. It registered the logger, plugin can see it. But the plugin itself is the bitmap to PNG converter. So it needs to also provide back to the core application, like, hi, I am this plugin, here is my instance. So you have core dependencies flowing into the plugin and the plugin interface or the plugin implementation going back the other way. That's the first line. Sorry for the lack of arrows. The second line is very interesting because I'm going to take the exact opposite approach. Core application still responsible for plugin loading, but you can have a plugin that says, I am the plugin that can define how we do logging. I am the plugin that defines how we can do telemetry, which is really interesting because now you have plugins that are basically injecting core functionality back into the core app, and other plugins can start pulling this information. Sound kind of weird? Because it is. So the next slide I want to show you. Can you guys see that? I don't know how to zoom in effectively on this thing, but this is the screenshot from a project that I have. So I'm building some social media content stuff in a product called Brand Ghost. And this is an example of basically both of the solutions that I showed you on the previous page combined together. So what that means is that I have social media plugins for being able to post to social media platforms and read social media content. Those plugins define basically capabilities that I want the core application to be able to access. Here is how you post to Facebook. Here is how you post to LinkedIn. But there are other plugins, and I want to see how far down it is. The third plugin down where it says Nexus AI features exceptions, that tells the application how to handle uncaught exceptions. Right? That's not a social media platform. This is literally core logic. There's another one for logging, and I'm using Serilog in this case that was mentioned earlier. There's functionality for sending email notifications. So I'm telling the core application, you want to send an email? Here is the implementation. We're using Azure email for that. So you're able to provide that functionality back into the core app. Okay, here's another bit of code. I didn't want to flip back and forth between Visual Studio, and I'm kind of thankful I took screenshots because I'd probably mess this up real bad. But the left side is an example of an interface that we could have for a plugin. So your core application would be able to look at something like this. But you would probably structure this, a picture would have been good for this because I need my hands again. You would probably have a shared library that defines your interfaces for your plugins. And what I mean by that is you would put this interface into a project, separate DLL that says, it might be like your SDK for plugins. This way, your core application knows the interface because it can see that SDK, and plugins can also depend on that project as well. They can still see that interface. Now, in this case, this one's called Post Content Handler. So it's an interface for being able to post to social media platforms. Now, what I think is really cool about building plugins, and one of the reasons that I get obsessed with plugin architectures, is because we get to use my favorite design pattern, which is one flavor of it is on the right here. This is a facade. So the facade design pattern hides complexity behind an API. And I don't mean like a web API, I just mean like an API in your code. You can write the signature of the method that you want to have. In this case, I have try to post content. I'm using my own custom result type. That's why I feel like, what the heck is this? It's some custom code. I don't like throwing exceptions. If you watch my videos and stuff, you'll be like, Nick hates exceptions. This is why. But in here, this facade basically makes it look like, hey, you want to post content? No problem. Tell me what you want to post. But the facade knows how to go look through the plugins that support posting content. So it can make the decision on behalf of the caller to do the right thing. So you can basically leverage facades in all sorts of different ways to load the right plugins and leverage them accordingly.
Is this essentially just componentizing the core concepts via plugins?
Yes. So to repeat the question, and I don't want to butcher it, but is this essentially just componentizing core pieces of logic? So great question. So the answer to that is yes, it can be. for a lot of the applications I build now, and I'm not saying this is like, you know, air quotes best practice, I use plugin architectures for like everything. I'm not saying that's the right way to do it, but when I'm building stuff, especially on my own, it's where my brain goes. So it's the most effective way for me to build. If you're building stuff on Teams and you're like, hey, I watched this guy on a stage who's really short and he was like, build plugin architectures for everything. Like, that's not what I'm trying to say. So you don't want to impose this on your teams. When you're talking about taking core application logic and then componentizing it, I would say yes for the most part, but a pattern you want to look for is like, do I have another feature that is maybe a different implementation but looks similar? So the examples I tried to give at the beginning, I was trying to touch on that, like I need to convert media, right? It's the same type of work, you're just doing it a different way. This example for posting to social media platforms, the activity you're doing is posting to social media platforms. How do you actually do that? That's where the plugin implementation is something you can swap out. When we talk about making plugins for things like, I'm going to change my logging implementation, that's where I would say like, you maybe don't need plugins for that, but I just like doing it. So I hope that helps. So yeah, facade design patterns, they're awesome. Use them, they're cool. Okay, so gotchas, everything has pros and cons. That's even though I keep talking about plugin architectures and facades and how much I love them, everything has drawbacks. So, you know, you don't want to be dogmatic about anything. You always want to be analyzing pros and cons, except C# is the best. So just use that for everything. Just kidding. So plugin architectures can add a ton of complexity, a ton. And I kind of tried to demonstrate that earlier with the pictures where you're combining different plugin groups together and stuff. So again, you can have really complicated build systems and deployment pipelines and things like that because of that. Something I didn't even want to try and make pictures of was if you're making plugins that third parties can implement, like what's the lifetime of those APIs? Right? So you're like, hey, we ship this thing, you can make plugins, this is version 1. And then a week goes by and you're like, oh crap, like wish we could just add a parameter onto that method. Or like we wanted to switch the interface, like, like what do you do? Do you tell everyone who is building plugins, your community of plugin developers, hey, like, sorry, we're cutting it off? Or do you incur the development cost of saying, now we have, you know, X number of APIs, we have to have a schedule for deprecating. So it can get pretty nasty, especially with third-party plugins. And the final part I wanted to mention here was really just when you're debugging stuff, especially with facades, you might say, hey, look, we're hitting this method signature. Cool. It says post to social media platform. Simple. And then you look and you're like, oh, it's a facade. Okay, well, which one of the 300 plugins is it calling? So now you have a different set of problems to go solve, which is your debugging might get a little bit messier. But if you get more used to it, you can navigate your code base, it's not so bad. I'm going to try to jump through this list super quick. I just wanted to touch on different things I've built with plugins. So the digital forensic tools I mentioned earlier, some examples of plugins were for exporting. So we would have these case files, say with hundreds of thousands, millions of pictures, chat messages, and things like that. And different forensic examiners would want to see that in different forms. They want HTML reports. They want PDF reports. They want CSV reports. I don't know why you would want a CSV report of that, but they want these different exports. So we have plugins to pick the export type. Same activity, different implementation. I already mentioned the mobile device acquisition, so we could run different types of exploits or different acquisition techniques to pull that data back. In the forensic tools, the weird word is artifacts. You can think about it like different applications that we support recovering. It's a big fancy search engine, but all of the different things that we support recovering are little plugins. And I say we, I don't work there anymore, but support hundreds of different applications you can recover data for. Meal Coach was a nutrition platform I tried to build as a side project. It failed miserably, but it was a lot of fun. I built this with vertical slices, but every vertical slice was a plugin. You could deploy the whole application and say, nope, we don't even want this feature or the projection, and it's just gone. Or you could add it back in. Brand Ghost is the thing I'm building now. I showed you some of that code. Also done in vertical slices, but the social media platforms are one type of plugin. And I've been building an RPG for about 20 years now, my first project that I'll never finish. And the entire thing is plugins, like literally every piece of it. So it's just something that's stuck with me for a long time. And I love building plugins. So That's it. So I just wanted to say, have fun building plugin systems. They're a lot of complexity, but they can be really powerful if you know what you're doing. And if you want to find me, I picked Dev Leader as a brand in 2013, and I stuck with it when I revived it last year. So Dev Leader. And yeah, so if you want to learn C# and stuff, I post all of my content is basically on C#, so you can find me online. So thank you.